Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshop and exercises to learn about AWS services. These workshop and exercises are published to our website aws-dozo.com. Today, I am going to talk about how you can use AWS Lambda to create a user-defined function in Amazon Redshift. This is a new feature which has been recently launched during the reInvent time, and I want to talk about it today. So just to give you introduction, in Redshift, you can define custom functions or user-defined function which you can use with your SQL query. And these functions you can use into the select part of the query and also in the where clause of the query. And with this support of Lambda function for UDF function, now you can define the whole business logic for the function in the Lambda function, and then use this Lambda function to create a user-defined function, and then you can use user-defined function into your query. And by doing so, actually, it really enhances your capability because now you can use first-class programming languages like Python or Node.js to create a Lambda function, which can then be used as an UDF function. So you can really leverage the capabilities of these programming languages. So let's understand what it takes to create a UDF function based on Lambda function. So assume that you have a Redshift cluster and database. So first step you do is that you create an IAM role for Redshift, and you associate this IAM role to the Redshift cluster. This IAM role should have permission to execute the Lambda function. So the Lambda function which you want to use to create your user-defined function or UDF, this role should have permission to execute the Lambda function. So basically, when you run the query inside Redshift clusters actually invokes the Lambda function for that query. So Redshift cluster should have permission to invoke the Lambda function, and this role provides that authorization. So once you have defined the role and give it permission to the Lambda function, then you use this external function, you create external function. So basically you're creating a user-defined function, and in this user-defined function, you simply use Lambda function as a function for the business logic. And once you have defined the user-defined function using the external function, then you can query this UDF into your SQL statement. And when you call this UDF function, actually this UDF function in reverse uses Lambda function to provide you the result. So this is what it takes to create a UDF function in Redshift using Lambda. So I'm going to go through some of these important components in little more detail so that you understand the whole concept more. So to start with, the IAM role which you create for the Redshift cluster should have invoke permission to the Lambda function. So this is the minimum permission it needs. So suppose your Lambda function is a my function, then this IAM role should have invoke function permission on this function. Okay, so this is the minimum permission you need to provide to this role in order to Redshift to be able to invoke the Lambda function through UDF function. Okay. Now the next component is what it takes to create the Lambda function. Now the creation of the Lambda function is actually same as you create any other Lambda function. But when you are giving the result back or output back, you have to take care of it in a certain format. So when you give the result back, actually your output goes back as a dictionary. So your output is a dictionary, and this dictionary should have these 4 fields. So for instance, the first field is success, and that value should be either true or false. True means your Lambda function has been successful, and false means your Lambda function has failed. So you might want to implement exception handling in your Lambda function, and based on the exception handling, you can set the value as true or false. If you have set the success value as false, then you can provide error message into this error message field. So you can provide what error occurred due to which your Lambda function has failed, so that this error message is passed back to the query, so that the query, the person who is running the query can come to know where in Lambda function the things have failed. So again, you populate error message only when your success is false. If success is true, then you don't need to populate because your Lambda function anyway has been successful. Now, your result actually could have multiple values. It could be a single record into the result, or it could have multiple records. So basically, the result is nothing but it's an array of records which you can return. But when you're returning it back, actually you can also populate a number of records field to say how many records you are returning. Now, in my personal experience, I have seen this number of records field is optional, but I think it's always good idea to populate the number of records when you are returning the result back. So these 4 fields are mandatory. So you return a dictionary, your output is a dictionary, and that dictionary should have these 4 fields configured or populated when you are returning the result back. And this is the only mandatory thing when you are trying to create a Lambda function which will be used along with a UDF function. So just to give you an example of a sample over here, you can see here that we are passing an array of arguments, and this argument has got quantity and price populated, and what we are doing, we're multiplying quantity and price, and that we are then appending into an array. Okay, say res as an array. Now this is my return, which is a dictionary type, and then I'm returning the return variable. But before I return the return variable, I have to pass success as true or false, and then result is equal to what array of result you want to return. In this case, it was a res. Okay, so again, you see that in this one, I have not populated number of records, but I think it's always good practice to you populate it. And there is no error message over here because in fact, I have not done any exception handling over here. But yeah, if you do exception handling, then of course you have to populate success as either true or as false. So this is an example how you turn the Lambda function output. Now, moving on, how do you define the external function? And this is the syntax you use to define the user-defined function or external function. So basically, you're saying that I want to create or replace an external function. Then you provide your UDF function name over here. Then you provide the parameters, your return type, and then finally you're saying that this is the Lambda function I want to use for this UDF function, and then you also provide the role ARN. And this is the same IAM role you created earlier for the Redshift cluster. So if you see, this one is an example. So I'm, for instance, creating or replacing an external function, which is this is the name of the UDF function. I'm passing quantity and price as 2 parameters into it. My return is varchar. To be honest, I'm multiplying quantity and price, and result ideally should be integer, but I think I did a mistake over there. Result is a varchar over here, and then this is the Lambda function I'm calling, and this is the ARN of the role, and this is the Redshift cluster role, which authorizes call to the Lambda function. Okay, so this is how you create a UDF function. And once you have created the UDF function, you are all good. You can simply use that into a query. And this is an example of the query. So for instance, in this one, I'm running a query where I'm reading records from order details table. So I'm saying my order number, quantity ordered, price, then I'm calling the Lambda function. In fact, I'm calling the UDF function, which is in reverse calling the Lambda function, and I pass quantity ordered and price each as a parameters to it. And whatever results comes out, I simply give that field a name or alias called total price. So when I run this query over here, this query is going to call this external or UDF function dozo Lambda function, which in reverse is going to call the actual Lambda function to give me the result. Okay. Now, one of the things you see is that, okay, so you are creating a UDF function, which is calling a Lambda function in reverse. So the question is, how many times Lambda function will be called? And that is a very interesting topic to investigate, because a lot of things depend on that. For instance, when you are calling a Lambda function, if you're calling Lambda function more times, then you are paying more price. Okay. Second is, each account has Lambda concurrency configuration. So you might not want to run in a scenario where you're using a lot of UDF function with Lambda function, and suddenly you start hitting your concurrency configuration. So it's really important to understand how this Lambda function gets, how many times this Lambda function gets called. Now, there is no fixed formula for that, and it really depends on how you use it. So it's really very important to understand how you use the Lambda function, and based on that, you can determine how many times your Lambda function will be called. So I'll give you 3 examples. 2 examples I got from the AWS documentation itself, and 1 example I'll give you from the exercise which I have built for you for this video. So the first example is, there's a Lambda function called Lambda multiply, where if you pass 2 parameters, it will simply multiply and give the result back of that. So in this case, I'm saying select AB from table T1, where Lambda multiply, and I'm passing these 2 columns value over here equal to 64. That means for whatever row A into B is equal to 64, that is what field I'm interested in. Now, in this example, actually Lambda function execute for each row. That means if table T1 has got, say, 100 rows, then 100 times Lambda function will be called, because for each row we have to multiply A and B and then see if the result is equal to 64 or not. If it is equal to 64, then that is returned, otherwise it's not returned. It's filtered down. Okay, so this is an example where your Lambda function is getting called for each row. Now I'm going to run this query again in another example, but we'll make a small change, and you will realize how the whole thing's changed. So for instance, the second query, and it's a similar query, it will give the same result. So what we're saying is select A and B from T1, where A into B is equal to Lambda multiply 2 into 32. That means wherever A into B is equal to 2 into 32, okay, assuming this Lambda function actually multiplies the 2 parameters, give me that result. Now this will give me the same result which I got from the previous one, but in this case the Lambda function is called only once, because one time I need to pass 2 and 32, which are the fixed values over here, to the Lambda function, get my result back, and simply use that output to compare each of my row. So I don't need to call this Lambda function multiple times because my parameters are fixed over here. Again, 2 queries giving the same result, but in this case it is running for each row because my parameters are columns, and in that case it is simply running for each row to calculate value at each row and then comparing. In this case my parameters are fixed, and in that case I need to run it only once and then compare that with the multiplication of row and column in the where clause. Okay, so this is a very good example to show how you could be smart in terms of using the Lambda function to ensure that you call it once or call it multiple times. Now another example is what if I use this Lambda function into my select query? Like in this case, I'm calling select order number, quantity ordered, price each, then and then this UDF function, quantity ordered, price each from the order details. Now this gives impression that probably it will run once for each row because it needs to provide quantity ordered into price each as a return value. But that is not true. It is called only once. Reason being that when you call Lambda function or call UDF function based on Lambda into your select query part, then what will do is that it will pass quantity ordered and price each as an array to your argument. So it will send you an array of argument, and each argument will have quantity, order, price each per row. And then what you need to do into that Lambda function is that simply loop into this argument, multiply value at each row, and then augment that result into a return array and then pass back. So again, you're calling Lambda function only once, but then you are actually looping into the Lambda function for each row. So just to give you example, I think I showed you the earlier example, which is a similar one. So you can see here the quantity and price has been passed, and then your arguments array will have this quantity and price at index value 0 and 1. So we are simply multiply quantity and price, and then we are appending that into an array, and then that array is returned as a result to the return dictionary object. Okay, so this is an example where you can see that even if you are calling this UDF function into your select query, still it is getting called once. Now you have to be a little careful over here, because you have to see that your Lambda function has a expiry limit. Since you're looping inside this Lambda function, your calculation should not be so complex that your Lambda function will expire even before it can give you the result. So those things you have to keep in mind, but at least you know it is smart enough to pass your row value as parameter, as an array to your Lambda function, so that Lambda function can simply do calculation for each row in one execution and give you the result back. So this one is very important to be careful about and test a bit to understand how you're going to use Lambda-based UDF into your query. Now, what are we going to build today is that we'll have a Redshift cluster, and then we'll have a Lambda function, and then we'll create a UDF function based on this Lambda function, and then use that into query. Part of this code I showed you into examples earlier, but we are going to build everything from the scratch, and that will give you a very good idea about how you can create a Lambda-based UDF function inside Redshift cluster. So in order to do this exercise, we have created a exercise which is published to our website aws-dojo.com. I'm going to walk you through the steps of the exercise so that now you can understand what's happening on each of these steps, and then you can run this exercise on your own to learn about creating UDF function in Redshift using Lambda function. So without wasting any more time, let's jump onto the exercise. Here is the exercise published to our website aws-dojo.com. These are the steps involved to run this exercise. Let me walk you through each of the steps. The first step is to create AWS account, to have an AWS account. And if you don't have any AWS account, you might want to use this link to create one. The second step is to create an IAM role for the Redshift cluster. So we simply go to AWS Management Console. We say this is IAM role for Redshift. Then we simply provide it power user access. So yeah, I should have given permission only for Lambda function execution, nothing more than that. That is the minimum thing required, but I have been lazy, so I simply used power user access. Yeah, but you might want to do the right thing. Then you simply give this role a name called Dojo Redshift role and simply create the role over here. So once we have created the role, we are now launching the Redshift cluster. So we go to Redshift Management Console. We are seeing we are creating a cluster. We give this cluster a nice name called Dojo Redshift free trial account, free trial configuration. And then we simply provide the database name and the username and password. And one very important thing is that in this cluster, we associate this cluster with Dojo Redshift role, IAM role, which we created earlier, because you want to authorize this Redshift cluster to be able to call Lambda function. And then we simply create the Redshift cluster. and these are the various parameters about the Redshift cluster. So cluster name, username, password, and database. Now our Redshift cluster is ready. Now we simply create a database and some, database is already created. Now we create some table and data into table so that we can use that for the query purpose. In order to do so, we simply use this query editor to connect to the Redshift cluster, and then we simply run this create table statement to create the table, and then we run this insert into statements to create the records into the table. So nothing fancy here. We are simply creating a table and then creating records inside that. Once that is done, our Redshift cluster is ready. Now we need to create a Lambda function, which will be used by the UDF function. So we simply go to Lambda management console, and then we say we want to create a new Lambda function. We give this Lambda function a nice name, Dozo Lambda function. My runtime is Python 3.8, and then simply provide basic Lambda permissions, nothing more than that, and we create the function. Once the function has been created, we have to update the code of the function, and this is how the code look like. So remember that we are passing quantity and price as two parameters to this to the UDF function. So those two columns will be passed as part of the arguments array. So what it is doing is simply looping into the arguments array, fetching quantity and price for each row, multiplying them, and then appending them into one of the result arrays. And once I have processed all my rows over here, we simply populate the return output dictionary, and we say that, okay, my success is true and my result is this result array, and we simply dump it back. So this Lambda function will simply take care of creating a new column altogether, which will be a multiplication of quantity and price at each row level. So once this Lambda function has been created, we simply go and deploy the Lambda function. Now Lambda function is ready. Now we can create a UDF function. In order to create a UDF function, we go back to Redshift cluster, and we connect to the query editor. And then we simply run this statement over here, which is to create an external function. So we are saying we are creating or replacing external function. This is my function name. Quantity and price are two parameters. Both are integer type. My return is varchar, which I think I made a mistake over here. Since I'm multiplying integer to integer, my return should be integer, but I somehow return the value as varchar. But you might want to correct it, and you say, okay, my return is integer. Then we provide a Lambda function name over here, which is similar to the name, same name which you created for the Lambda function, and then you provide the role ARN. And you run this statement, it will create a UDF function with this name, which is going to use this Lambda function. Now, once that is done, it's pretty straightforward after that. Then simply you make a call, select order number, quantity order, price each, and then call the UDF function, passing quantity order and price each as parameters. And whatever value comes out, we are giving that column alias name called total price from the order details. And when you run this query, actually it simply returns your order number, quantity ordered, price each, and then total price, which is nothing but the multiplication of your quantity ordered into price each. And that pretty much that finishes this exercise. The next step is to go and clean up the resources so that you don't incur any cost post the exercise. So that was all for today, guys. Hope you like this video, and if you like this video, please click on the like button. Please subscribe to my channel. There are many other workshop and exercises similar to this which you can use to learn about AWS services. These workshop and exercises are published to a website, aws-dozo.com. If you have any comment, feedback, or request for new content, either you can provide in the comment section of my YouTube channel, or you can also click on the contact us tab over here and can provide feedback over here. So that is all for today, guys. I look forward to your feedback. I promise to come back again with another video in next couple of days. In the meantime, please stay safe and have a nice day. Bye-bye.